All right, guys, welcome to your study guide for our Unit 11 test. I'll be going through the even problems. The first couple problems we're going to go through is solving equations that have rational expressions in them. This was the last topic we talked about. So let's begin. The first thing that we want to do is we want to multiply to cancel. I recommend putting binomials in parentheses, by the way. So I'm going to multiply this entire equation by something. I want it to cancel out a 4 and a 2. So to do that, I would need to multiply by something that can be divided by both 4 and 2. And so a number that can be divided by both 4 and 2 is 4. So I'm going to multiply everything by 4. Also, I want to cancel out x squared, and I also want to cancel out x. So I need to multiply by x squared. That will cancel out both of them. So I'm going to multiply each fraction on the top by 4x squared. And as a result, I will have the following. So step 1 is to multiply to cancel, all right? Step 2 is going to be to reduce. So as you guys can see here, these x squareds can go away, and 2 goes into 4 twice. As a result, we now only have 2 times x minus 5 left there. For the next one, this x will take away one of the x's on the top, leaving me with just 1x. And so we have 1 times 4 times x there, which is 4x. Finally, last one, the 4's cancel. And this x takes away one of the x's, leaving me with only 1x. So on the top, I'm left with 1x. Okay. So step 1 is multiply to cancel. Step 2 is to go ahead and do the canceling. Step 3, we're ready to solve this thing. Whenever you're solving, the first thing that you want to do is distribution if it's there, and it is in this case. So I'm going to multiply that 2 into the parentheses. Next, we want to combine our like terms. So like this 2x and this negative 4x are like terms. I can put those together. And then I also want to get this 2x and the 1x together, so I'm going to add 2x on both sides to cancel it off of this side, and giving me 3x on the other side. Finally, to solve for x, we just divide by 3, and we have our answer. Okay, so there is that one. Let's go ahead and move it along to number 2. This is also solving equations, but the difference between this problem here and the one we did before is that these are polynomials, and when you're working with polynomials, you have an extra step to do at the beginning. The extra step is factoring, so you would need to factor. Now you need to remember your factoring strategies. We've learned 3 different factoring strategies. One of them is the box method, the other is a GCF, and the other one's a difference of squares. You should always look for a GCF first, but as you can see, there's no GCF here. There's nothing that those have in common that I can divide out. So we'll skip GCF. Next, because it has 3 terms, we're going to go with the box method approach on this one. So we put the first term here, we put the last term here. We find 2 numbers that multiply together to make p squared and put them here. And then we find 2 numbers that multiply together to make 6, and we put them here. And then we have to adjust the signs so that when we complete the box, these 2 numbers should add up to make the middle. If they don't, then we've done something wrong. But nevertheless, this factors into p minus 2 and p minus 3 then. So that's the new first step. The rest of it is really not different at all than the last problem. So now what we're going to do is what we did first on the last problem, which is multiply to cancel. I'm going to multiply this entire equation by p minus 2 and p minus 3. That way, it will cancel out all my denominators. Oh. And we're going to put that p minus 2 and p minus 3 on the top of each one now, representing the multiplication. And then we're going to cancel out whatever we can. So in this case, these cancel and these cancel, leaving me with just 1. In the next case, only these cancel, leaving me with a 1 and a p minus 3. I think I'll do that in black, sorry. All right, and then the next one, these go away and these go away, leaving me with just a 3. All right, once again, now we're at the solving step. So we're going to start by distributing once again. So that's going to be 1 plus p minus 3. Then we're going to combine our like terms. Those make negative 2. And then finally, we'll add 2 on both sides to get our final answer, which is 5. Okay. Now, technically, when you're doing these problems, there is a final step that you have to do. You want to make sure that this answer is actually allowed. And what do I mean by is the answer actually allowed? If I were to plug my answer in here, 5, would that make either one of these equal 0? Well, 5 minus 2 is 3, and 5 minus 3 is 2. So no, it doesn't make 0. So these are good answers then. If you ever plug it in and you get 0 in the denominator, that means that our answer is a false answer, and we would throw it out and say there's no solution. So just be aware that technically you are supposed to check for false answers known as extraneous solutions. All right, and we'll do one more problem here of solving rational equations. I'm going to buzz through most of the steps because they're pretty much all the same, though, until we get to the end. So step 1, once again, is to factor the denominators. So in the beginning here, that one has a GCF. I can take an n out. So that's step 1. Step 2 is to multiply to cancel. Notice I'm going to multiply by both n and n minus 5 to cancel out the n's and the n minus 5's for each one. So let's go ahead and put those on the top of each fraction. All right, that's what that would look like. Next, these are going to cancel out, leaving me just with the 3n squared plus 12n minus 15. Next, these are going to cancel out, leaving me with just a 1. And then last of all, these are going to cancel out, leaving me with n minus 4 and n minus 5. Okay, so our next step now is to start simplifying this. So first of all, this one, we're going to need to multiply those together using the box method. And on this side, we can combine the negative 15 and the negative 1. So on the left side, we have 3n squared plus 12n minus 16. On the right side, though, like I said, we've got to figure out what this is using the box method. So I'll show my work here. So it's n squared. Combining these like terms here, we get minus 9n plus 20. Okay? Now, notice that on this problem we have squares on both sides. That means we have a quadratic, and when you have a quadratic, you need to move every term over to one side so it equals 0. So I'm going to subtract n squared on both sides. That way these That way these cancel out. I also want to add 9 on both sides, 9n. That way those cancel out. I also want to minus the 20 on both sides. That way those cancel out. And therefore on the right side all I have is 0. And once I combine all these together on the left side, I end up with the following. Okay? So that's the first thing you have to do. It's a little bit different when you have a quadratic, is you got to move everything over to one side and get it to equal 0 at this point. Now the next thing you want to do is factor it using your box method. So we're going to put the 2n squared here and the minus 36 here. And we'll go ahead and fill in our box. It might take you guys a little while to figure out what pair would work for this, but I've kind of worked it out a little bit in advance, and it's this pair, positive 12 and negative 3. How do I know that's the pair? Because these have to add up to make the middle, which they do. So now I've got 2n minus 3 and n plus 12 equals 0. You set both of these equal to 0 and solve. So I get n equals 3/2 for one of my answers. And for this one, we get negative 12 as an answer. Once again, you do want to make sure that it doesn't make your denominators equal 0. But if you take a look, if I plug in 3 here or here, 3 over 2, neither one of those is going to make 0. And if I plug in negative 12, that's not going to make 0 either. So both of these are good answers that I will keep. All right. Let's go ahead and move on to our next problem. We're going to switch gears now and talk about complex fractions. This was a different lesson. This was a lesson 11.5, I believe. So for this one, what you're going to do is you're going to do top divided by bottom first. Next, we do same, change, flip. At this point, if you can cancel anything out, go ahead, but we can't. On the bottom, we have an x plus 2, but there's no x plus 2's on the top. And this is a 1. That's not going to cancel anything either. So, but if you can, do reduce. But from here, we'll go ahead and simplify. We multiply the tops together. X squared times x is equal to x cubed. And then x plus 2 times 1 is just going to be x plus 2. So there's our final answer there. Sometimes your complex fractions have a lot more to them. In this case, notice that the denominator here has two fractions that are being added together. So when that's the case, whether it's in the numerator or the denominator, what we're going to do is we're going to start by putting those together first. So I'm going to have 2 over m minus 5 plus m minus 5 over 6. We need to get a common denominator. So I'm going to multiply this side by 6 on the top and bottom. And I'm going to multiply this side by an m minus 5 on the top and bottom. That way they have the same denominator. So we have 12 over 6 times m minus 5. Plus, we'll have to do a box method for that. M minus 5 times m minus 5. So we have m squared. Those are like terms, so negative 5 and negative 5 makes negative 10m. And there's 25. So now we've got a common denominator, and we can put these numerators together. 12 and 15 are like terms, so we can put those together. 12 plus 15 is 37. So that's the first thing that we need to do when you have a complex fraction that has two fractions in the top or bottom, is you need to put those two fractions together. So the top is 3m minus 15. The bottom now is going to be this. It was this up here, but we put it together, and that's what I'm going to put here now. All right. After that, the steps are kind of the same. We do top divided by bottom. So it's going to be 3m minus 15 divided by m squared minus 10m plus 37 over 6m minus 5. Think of that as a fraction. Okay, we're going to do same change flip. So same change flip. All right, and so now we're just going to put these together. The tops go together. And we multiply the bottoms together. Now, sometimes it might be okay to leave your answer like this, but sometimes not. So they might want you to go ahead and multiply these together, which I'll go ahead and do that. It just depends on a multiple choice test. If you see that answer there, then go ahead and pick it. If not, try to go a little further until you get to the answer that they want you to have. So the top becomes 18m squared. And then we put these two things together. And then the 225. The bottom's already simplified, so we'll leave that alone. And there's our final answer. All right, now we want to just move into adding and subtracting. Now, sometimes what's happening here happens, but sometimes it doesn't. I noticed that I can reduce these, like the 5s can cancel and the 4s can. So before you add and subtract, if you can reduce first, it might make your job a little bit easier. But it may not be like that, but just letting you know. All right, now before you can add and subtract, you need the denominators to match. And I noticed that if I multiply this side by a b squared, I can get it to have a b to the third power. Whatever you do to the bottom, though, you do to the top. So now we have the following. And at this point, they will both have a common denominator. Since they have a common denominator, we could put the numerators together over that common denominator and be all done. So we need a common denominator. Let's take a look at another one. In this case, notice they already have a common denominator, so we could just start combining right away. I like to start with parentheses around binomials usually. But yeah, since they already have a common denominator, we can just put them together as one big fraction now. But you got to be careful with the subtraction ones because you do have to distribute that negative in there. After you distribute the negative, you can get rid of the parentheses. The parentheses are just there to remind us to do the distribution. So the k's go away, And then -3 and -1 leaves me with a -4 on the top. Sometimes these can be reduced at the end, not usually. So I would say at this point, go ahead and just see if your answer's there. If not, try to reduce it. All right, let's go ahead and move on to another one. So we have unlike denominators here, and it's a lot like the one we did before because this one also had unlike denominators. But this was monomials. On this one, we have unlike denominators, but with polynomials. When that happens, you do need to factor first. I'm going to reduce again. I think we can get rid of the ends here. Now, for this guy, that is a GCF problem. I can take a 3n out of there, and if I do, that would leave me with n minus 6. Right? Now we need to get a common denominator. So the right side needs an n, and it also needs an n minus 6. Now they both have the same denominator. So we have n plus 6. And on the top, I'm going to go ahead and take this 2n and distribute it. And now that we have a common, it's supposed to be an n there. All right, now that we've got a common denominator, we can go ahead and combine these together. Combining like terms, I've got a 2n squared there, which stays the same. I could put this n and this minus 12n together to get negative 11n, and then 6 doesn't have anything to combine with, so that's going to stay there. And at this point, I would just check to see if my answer was on the multiple choice test. If it wasn't, that might be a clue that if I didn't do something wrong, maybe I just need to reduce my answer. I'm looking at this answer, though, and I see, okay, that's the answer I have. They have the top numbers in a little bit of a different order, but it's the same answer. So we're good, and we don't need to reduce. But do be aware, sometimes you might have to reduce if you don't see your answer and you're feeling confident about how you did it. All right, we have another subtraction problem here. So let's go ahead and get started. First of all, once again, this can be reduced, so I like to start by reducing any fractions that I can. Next, we're going to factor that. That's a box method factorization. Now we want to get a common denominator. So I'm going to multiply the right side by a 3 because it needs a 3. The left side needs an x minus 3 and an x minus 4. Put these together, we get 9. I'm going to put this stuff together. X minus 3 times x minus 4, we already know what that is. It's what we started with up here, so I'll just steal that answer and plug it in there. Now that we have our common denominator, we can go ahead and combine these together. And in this case, the 9 and the 12 can be combined together. that would be our final answer there. Once again, maybe it could be factored and reduced, but probably not. We'll move into talking about multiplication. When you're multiplying rational expressions, first thing you want to do is factor everything you can. On the top, I can take out an 8x using the GCF method. Same thing on the bottom, I can take out an 8x. And then anything that's the same on the top and bottom can cancel out. So the x plus 4s can go away, and the 8x's can go away. And I'm left with x minus 10 on the top and 5x on the bottom. And that would be my final answer there. So with multiplication, it's just factor and cancel. Division is pretty similar. It has a different step in the beginning, though. The first thing you want to do with division is do same, change, flip. So we leave the first fraction the same, we change it to multiplication, and then we flip the second fraction over. But after that, you're just going to factor and cancel. X minus 9 doesn't factor, and neither does x minus 2. But the one on the bottom left does. I can take a 4x squared out of there, which would leave me with that. And in that case, these cancel out, and I'm just left with x minus 9 over 4x squared. With these types of problems, all you need to do is reduce it. So it's a lot, but it is a lot like the multiplication. You're just going to factor and cancel. So let's go ahead and do that. All right, so for our next one, we're going to simplify. We'll go ahead and factor. As for this guy up here, we're going to take out a GCF. And then for this guy here, we're going to do the box method. So we end up with x plus 2, x plus 4, and then these guys cancel out, and we got our final result there. So to reduce, you just factor and cancel. Let's take a look at the next one. Same idea, but we're just doing monomials. For monomials, you're just going to reduce the coefficients like you would normally reduce a fraction. You look for something that divides into both the 20 and the 32, preferably the biggest thing possible. I can divide both of those by 4 and get 5/8. As for the variables, we have 2 n's on top and 1 n on the bottom. And so this n on the bottom is going to take one of the n's away on top, leaving us with a single n on the top. Next, we'll talk about graphing. For these problems here, they're going to be set up in the following fashion. The H represents the, well, actually, let me write this out first. We have two asymptotes, a horizontal and a vertical one. The H will tell you what the vertical asymptote is. You have to remember to change the sign of the number there, though, because there's a minus in front of it. That makes it an opposite. And then the horizontal asymptote will be the K value. If we have a positive value, then our graph will look like that. Whereas if we have a negative value, then my graph would look like that, where those vertical and horizontal lines represent the asymptotes. So if your H and K are ever missing, that means they equal 0. So knowing all that, let's get started. In this case, I'm missing the h, which means that it's 0. So my horizontal asymptote is going to be y equals that number. My vertical asymptote is going to be x equals that number. So I'm going to graph both of those lines. Y equals 1 is a horizontal line. X equals 0 is a vertical line, and those are my asymptotes. Next, since we have a negative in the front, we'll be going with this shape, so the curves will be on the top left and bottom right, just like that. Do one more like that, just to bring it home, and then we'll be all done. So first of all, the horizontal asymptote is y equals this number. The vertical asymptote is x equals the opposite of that number. So let's go ahead and graph those. The horizontal asymptote would look like this. The vertical asymptote would look like this. And then since we have a negative in the front, the curves will be on the top left and bottom right. And that's that.